Hello friends, in this series of videos we are solving the problems related to database management systems, concurrency control and transaction management, which is a very important topic when you study database management systems. So this time we'll solve another problem. So this is a completely different type of problem. We have solved the problems related to serializability, identification of serializability, wait for graphs, precedence graph, all that problems we already solved it, right? So now I will focus on checkpointing. So this is a problem. I will focus on checkpointing. Probably in the next video I'll come up with a time stamping problem, which is also a very important thing. Thomas rate rule is very important in MCQs. It is being asked in many university exams. So both of them are important. So let's focus on this problem. What we are given is, so this is some transaction log of some database management system, right? Or any of we can consider any of the thing, right? So this is a checkpoint, and this is a transaction log of a database management system. What happens is after write of this there is a system crash, right? Now database management system has to decide which transactions needs to be undone, which transaction needs to be redone, right? Undo simply means a rollback sometimes, but yeah, they both are different. We'll see how they both are different. So we need to identify the transactions which need to be undone and which needs to be redone. So first let's identify that what are the transactions itself. So we have transactions like T1, we have transactions T2, we have transactions T3, we have transaction T4. Right, so we have four transactions we can clearly see over here. Now, if you are not aware about the checkpointing rules, I would better recommend you to go and read from some textbook. I will add up in the comments or in the description over here which where to read it. So the basic idea is that we first find the checkpoint, and the checkpoint, sorry, there was a connection mismatch here. So we are solving this problem, and so first we need to identify the checkpoint. What is the checkpoint? And then probably going forward, we will identify that what are the transactions which have committed before checkpoint, right? So checkpointing is like something like that. Okay, what do you mean by checkpoint? That is a very important thing. So before the checkpoint, everything has been committed and returned to solid or your hard disk. So that is what the meaning of checkpoint. So that let's say if I do not maintain a checkpoint, then and if a system failure occurs, then I will have to roll back and redo all of the things which I have done, right? Now this checkpoint means at least till before this point everything was fine, and this checkpoint means I am writing it to hard disk. So that is a typical meaning of a checkpoint. So before checkpoint, we clearly see that transaction T4 had committed. So transaction T4 had committed. So we will not have to undo, we will not have to redo, because T4 has nothing to do with this system crash, right? And even after system crash, before system crash, it is not starting it again. So T4 remains as it is. I mean, we do not need to do anything, not do anything, because it has committed before checkpoint. Okay, now we move forward. We'll analyze other transactions. We see that after checkpoint, we have a transaction called T2. Transaction T2 had committed. Okay, transaction T2 had made a commit after checkpoint, but before system crash, right? So whatever are the transactions which have committed and are after the checkpoint, we need to redo them. So in my redo list, so these are the basic checkpointing rules. If you are not aware, I'll post a description about that. So these are the basic rules. So we found out that T2 needs to be redone. We see that transaction T3 was doing some operations. It had started just a while, and after that a system crash unfortunately occurred. Right. So transaction T3, all of the operation which it did, it needs to be undone because it had not yet committed. If it had committed before the system failure, we will have to redo it. So basic meaning of redo and undo, if you are not aware, basically undo means control Z. So it is a bottom up approach, and redo means it is a top down approach. So that is a basic difference. If you are not aware, I think it should be clear now. What we are remaining with, we are remaining with T1. What do we need to do for T1? T1 had started, yeah, it had made some right transactions, yeah. We can see that T1 had started, but yet it had not yet committed. So that is a very important thing. Even the checkpoint had occurred, but since the transaction T1 had not yet committed, we'll need to undo all of its operations, right? Because if it had committed, let's say if it had committed before the checkpoint, then we would have to include it in this list. But since it has not yet committed, we will have to undo all of these operations. So what final result is, we do not need to do anything with T4 because it had already committed. It is already saved in my hard disk. We need to redo T2. We need to undo T3 and T1 transactions. So this is what we have learned from this problem. I'll try to solve another problem related to timestamping and Thomas Red rule, which is a very important thing in DBMS. So if you have any doubts related to this problem, comment it down. I'll try to solve them ASAP. Thank you for watching. Do not forget to like and subscribe to the channel.